Here I have a digital indicator mounted on a height gauge. The indicators are typically used to measure change in distance. If I move it up and down, it automatically turns on. So this one has a fairly light travel, 25 millimeters or 1 inch. And you can use them in all kinds of ways. For example, you can try to check the flatness and parallelism of this particular piece. So all one needs to do is to lower it a little bit. So it's somewhere in the middle of the range. Zero it. And then one can move the height gauge to see whether it's flat enough. So the display right now is in microns. Got about 20 micron or more variance, so not really that flat. There are situations where you don't actually want a manual device. For example, some of these can be somewhat finicky. Anytime you need to zero it, you have to press a physical button and this moves it a little bit. It's often much more convenient to have a computer control over the measurement. So one device you can use for this, and that is really quite nice, is an LVDT. I can show you one. Here is an LVDT. It's very similar to this indicator. Essentially, you can see this is just this piece that has a shorter travel, probably about a 1/4 inch or so. But on the other end, instead of a display, there is a plug. So normally the way that you use them is by connecting to some sort of device that digitizes the signal and sends it to a computer. Or there are also dedicated gauges. The old ones are analog, the new ones are digital, that do the same thing. There are all kinds of LVDTs. So this one is fairly long. This one's still in the box, so I don't really have a chance to use it yet. That is just much smaller and has a much shorter travel. This LVDT is similar to this one, but it has an additional feature where you can use compressed air, you can use pneumatics to lift it. So pretty cool. There are also LVDTs like these, which have a combination of an LVDT and an arm. So you can see there is a tiny LVDT right here, and there is this flexure that moves. The advantage of this arrangement is that in this LVDT, if you press on this point, the point can move not just in and out, but a little bit sideways, and that can manifest as an error in measurement. In this one, the sideways movement is eliminated, so it could be more precise. You can also obtain LVDTs like this. So this is a federal gauge head. So it was meant to be connected to an analog gauge. It's quite old. Here you have an arm, like in a dial indicator, and it translates this motion into the motion inside this measurement unit that actually then responds electrically. Now, if you don't have a gauge head, and I don't, it's actually fairly easy to make use of these. So what you need is an adapter that converts this type of plug, which with connections for the coils, to a 3.5 millimeter plug that you can just connect to any audio card. And in particular, you can buy these So this looks like an adapter, but it's an adapter from an analog to digital, so it has to have something inside. And this one actually has a 32-bit audio card. You can buy them in different kind of plugs, also micro USB. Some of these are 16 bits, some are 24 bits, some are 32 bits. Obviously, the more resolution you've got, the easier it is to work with them, because you don't have to worry that much about dynamic range, and in theory, at least your resolution can be better. The precision depends a lot on the mechanics. So you connect it like this, and now it's ready to plug into something digital. So this could be a Raspberry Pi like this one, a small adapter. I have example code for it. Alternatively, you can also use a phone. Get mine. So there is an app, LVDT, that if you start it, well, there's nothing plugged in, so let me see, like this. So now it actually is measuring. So as I move it, it measures. It's really quite sensitive. So the vertical line indicates the current position, and the blue band is range of measurements. And as you can see, I'm all over the place. Tricky. Well, it's a lot easier to use on a stand, so let me arrange that. So now I have a LVDT connected to the phone, so let's see what we can do. Okay, so this is much coarser scale. So you can see it is way more sensitive than the digital indicator I used before. This particular field allows to enter calibration. If I don't touch it, you can see that it drifts a little bit. So how does the adapter work? We disconnect it. It's really quite simple. So all you really need is a few resistors and a few capacitors. There is a website with a schematic and explanation how to build one. The exact connection to the pins unfortunately depends on LVDT. Some LVDTs use a plug like this, which is fairly common. You can see there are these pins arranged into a semicircle. All the federal gauge heads, on the other hand, use a very similar plug, but the pins are arranged around the circle. So you have to have an adapter for each of them. And I made one. And of course, occasionally get old used LVDTs with just wires snipped off. This is arLVDT, actually just Federal before Mar bought them, I guess. Quite sensitive. Let's see whether we can hook it up. Okay, so these two pins are 17 ohms. Let's see what amount we used to. Oop. These are 42 ohms. So the smaller one is just right for a headphone. So we will be driving this one, and then the other one goes to the microphone through a capacitor.